Fractional indices. Consider that using a to the m times a to the n is a to the m plus n, that 2 to the half times 2 to the half would be 2 to the 1, which is equal to 2. So we know that when we're in this situation, because of this index law, we add the indices, and a half plus a half is 1. And of course 2 to the 1 is just 2. But we know by definition that the square root of 2 times the square root of 2 is 2. So we also have here that root 2 times root 2 is equal to 2. So if we have 2 to the half times 2 to the half is 2, and root 2 times root 2 is 2, then it stands to reason that 2 to the half is the same thing as root 2. We can do the same sort of thing with a power of 1/3. So 2 to the third times 2 to the third times 2 to the third would be 2 to the 1, which is 2. And by definition, we know that the cube root of 2 is the number such that the cube root of 2 times the cube root of 2 times the cube root of 2 is 2. Just think about the fact that we know that the cube root of 8 is 2, and that's because 2 times 2 times 2 is equal to 8. So it follows that 2 to the 1/3 is the cube root of 2. Now we can generalize this, and it leads us to this index law. A to the 1 over n is the nth root of a. We can combine that with the a to the m to the n is a to the m n law to obtain that a to the m over n is the nth root of a to the m, which is the nth root of a to the m. Let's just go through that last part. So a to the m over n, remember that that is the same as having m times 1 over n. Now that could either come from a to the m to the 1 over n, or a to the 1 over n to the power m. Now in this case, what we're doing is we've got a to the m first, and then we take the nth root of that. And in this one, we've taken the nth root first, and then we raise that to the power m. When working with numerical answers, this one here is often the most useful because it keeps the numbers we're working with smaller.